Namaskaram everyone. Welcome back to the 19th episode of our Master Unreal series, and in this episode we are going to implement the mechanism that will allow you to move your pointer in the inventory grid. So let's just get started. Alright, so we are in our editor now. This is the progress that we did last time. Now let's create a function that will move our mouse pointer. So move case pointer. Now this mouse case pointer will receive an input, and that is move input, and type would be vector 2D. Let's just return it for now, save and compile. Go back to your third person character. In the inventory graph, we are going to drag the input actions IA move. So this is the input action that we use for moving our character, right? If I go to IMC default, you can say IA move has attached these keys with it, and this action value represents in which direction you are moving. So if I attach a print string and if I pass a value here and if I compile and play, you can see if I'm moving forward, y is 1. If I move backward, y is -1. If I go right, it is 1 in x. And if I go left, it's -1 in x. Now we are going to use exactly this input to move our case pointer. So this triggered pin execute every tick, and we don't want that because it is very fast in that case, and we do not want that kind of speed in the widget, because if you press even once, it will move 4 blocks ahead. So we don't want to do that. So for this, I'm going to create this variable, name it IA move value, and the type would be vector 2D, and I'm going to set its value here. Now once this is done, I will call this do once flow control. Now every time this completes, we need to make sure that your inventory is open. If your inventory is not open, then there is no point. So what I'll do is I'll go for a branch node. I'll get this inventory manager. I'll access the case actor and I'll check is inventory hidden. So if inventory is not hidden, then only we are going to move the pointer. So for this, I'm going to call the move case pointer from our inventory manager, and then I will get this IA move value, which will be updated every tick, and I will multiply it 1 comma -1 because x is fine but y was opposite, so we will reverse it and then we will connect this to move input. Now once you move that case pointer, we are going to add a delay, and that delay would be of 0.2 seconds, and once this delay is completed, we will reset this do once. So when this is executed first time, it will not execute further till this do once loop is reset, and that reset will only happen once this delay is over. Okay, as simple as that. Now save and compile. Also, we need to make sure that IA moved is allowed to trigger even when the game is paused. Now let's go to generic functions and let's create a function that will deduce the movement direction. So I'll go get movement direction, and it will accept one variable in input, that is direction vector, and the type would be vector 2D. We will split it and we will return it. There will be 2 pins in output. One is that it is not moving because it will be triggered every tick, so there is a possibility that you might not be pressing the keys for the movement. So idle is the case, and if it is not idle, that means it is moving in one of the directions, and to check that, I will say is horizontal. So if the movement is horizontal, then fine. If it is not, then it's vertical. But to get there, you have to check whether you are idle or not. Then I will check whether x is not equal to 0. So if x is not equal to 0, then it is horizontal, otherwise it is vertical. And if it is equal to 0, then we will check is y also 0. So if y is also 0, that means it is idle. Okay, as simple as that. Now save and compile and make sure this function is pure because it is not accessing or modifying anything externally. And now we will call that move direction here. This will get this. So if you are not idle, then only I would like to proceed. And then I would like to create a variable is horizontal movement. If that is the case, then we would like to plug this here. And then we would like to know how much you want to move. And that would be vector 2D. So I know that you will be moving one block at a time, but in the further logic, we would move more than one block. But in one direction only. So this is required over there, and I'll plug this movement input right here. And now I would like to create a sequence node. So first I would like to check if we are on some item, because if you equip an item, then the first slot, the 00 position, is filled by that item. And in that case, it's not one box that is active, it is more than one box. So I would like to know the selected item index, and I will change it to integer. So this will tell me if an item is selected, and I will check in the owned items that is this a valid index. If it is so, that means your pointer is on an item and not on a standalone box. So if that is the case, that means you would like to move ahead of it. So let's say if the size of item is x comma y, then we would like to move x plus 1, right? So to handle that, we will create a function and get pointer to adjacent box. So this will return me the position where you should go, because once you move the pointer, you want to get ahead of this item. You do not want to iterate over each block that is present in that item, that is occupied by that item. So we want to go next to it once you press the key. So to handle that, I would like to know that inventory item, and I want to know whether you want to move horizontally or vertically. And then I also want to know the direction value, that is 1 or -1 by default, but it may vary. So we would like to know that as well. And let's change the horizontal movement to Boolean, and the direction value would be float. So in the second parameter, you will give us the direction, and in the third, you will give us the value. That means either in the left or in the right. And after this, I'll create a variable that is item position. I'll change its type to vector2d, and I'll set its value. Okay, this should be s inventory item, correct here, and it will be grid position. Awesome. So now let's create a select and get the direction value. If it is greater than 0, that means you want to move in right or in bottom. So I'll go for the false case. That means you want to go in left or up direction. So I'll get the grid position. I'll subtract 1 comma 1, and this will go in this. Otherwise, I will perform an add. This will go here, and we will add the item size, of course, by flipping it. So use the get to the vector, flip it, and then edit. And this will allow you to go next to it by adding this size in your position. And if you are coming from right, then we will go one step before than this grid position. Okay, and now once this is done, I would like to go for select again, and here I will check is horizontal movement. So if you are coming from vertical direction, it would be a different scenario, and if it's horizontal, then it would be different. So I'll split this and I'll pull this here. Okay, and I'll plug this value here, and let's get rid of this. And this is assumed that you can only move in one of the directions. So if it is a horizontal movement, then we will plug x into x. And if it's a vertical movement, then we'll plug y into false y. But now we need to tell how many blocks we have to move to reach that position. We have just figured out where is that position, but now we need to figure out how many steps do we have to move. So I'll get this item position here, and I will also get this slot manager, and I will find this particular item position. So for this, I have to convert this point to string and pass it here, and this is vector, so we will pass this as true. Now this will tell us what was the item, so I'll add 3 pins here. First pin will tell us whether the item exists or not. Why I did this is because, so let's say if 2 items are placed next to each other, and then when you will reach to this particular block, there is another item. So we would like to know if there is another item. In that case, we would like to maximize the highlight area. Otherwise, it will be highlighting only one block. So we don't want that to happen. So that is what exist will tell us, and it will also tell us the item index, and we will change it to integer, pass it to this. This will go here. And for number of steps, I'll say new move by, and I'll get a select node, and I would like to subtract. And now we want the case pointer so that we can subtract this item position. So I'll go to the inventory case, and here I will create a variable case pointer, change this to vector2d, save and compile, go back to inventory manager, access that case pointer here, and we'll subtract this. Okay, we forgot to change the type, so let's change this to vector2d new move by, and break this pin, reconnect it, and then pass this here. And let's say if this is a 0 vector, then we do not want to pass 0 comma 0. We just want to say, hey, just move to the case pointer. So in that case, I would like to just pass this case pointer here. Now I hit compile. I can go back to move case pointer and I'll call this here. So if the active box is on an item, then I would like to investigate that. So I'll get this owned items, get, and I'll get the reference. There is no point of getting a copy because we are not modifying anyway, so it is fine. So I'll plug this here and the selected item index would be this. Is it horizontal movement? Let's call this node here and connect this to this. And about the direction value, let's go for select floats and use this same horizontal movement node. Get the move by pin, split it. So if it is horizontal movement, X will go here, otherwise it will be going with Y. And whatever the value comes, we are going to pass it to the direction value. Now let's remove this return node for a second. And now we can set this move by here. And now whatever new move by we have got, we will just multiply with this. It will only consider the value in which you want to move by multiplying it. So if it is 1 comma 0, then Y will go 0 automatically. And now since we have the move by, we can go to inventory case and I can say move case pointer. And this will ask you how much to move by. Now you can move diagonally as well. That's the reason we were multiplying over there. That function can only move the pointer in one of the directions, not diagonally. But our function is flexible enough to accommodate any kind of movement. So that's the reason. And then I'm going to use a sequence node. I'll get this move by and I'll perform an add, and this case pointer position, I'll just add this value. Now this will give us a value and there is a high possibility that it might go out of bounds. So in that case, I would like to go for utilities, generic functions, and here we will create a function modulo bounds. So what this will do, whatever value you provide, it will divide it by the case size, and whatever is the remainder will be considered as your position. So if the case is 10 by 10 and you are at 12, then 12 divided by 10 gives you remainder of 2. So you will come to the second box immediately instead of going to the 12th box. Okay, so I'll add a return node here, and in the input I will accept a vector 2D, and the max vector that you have to tell us so that we can bring it in bound based on that value. So I'll get the vector here and I'll also get the max vector and add 1 in each value. So go for float double precision. Now whatever the value comes from here, we will split it and then I'll perform the add. So X will go here, then you will perform the division, whole and remainder, pass this X in the divisor. And actually we don't need this one, so let's just remove this. I almost forgot this is not an index, and we don't need to add because it's the actual size. And let's duplicate this logic here, and Y will go here, this Y will go here, and this Y will go here. Okay, now we are good. So the remainder will be plugged in Y. And now in the inventory case, you can call that modulo bounds. This is the vector position that we are trying to reach. And the max one is a tricky one. Let's first create the max case area. So this max case area includes your discard case as well, because you do want to move in the discard case as well. So I'll perform a select here and I'll check if the discard case is active. So I'll create another variable, is discard case active. I'll change it to boolean. If discard case is active, that means I want to go for the max case area. Otherwise, whatever the primary case size is, just go for that. And let's compile this and put the max case area value to 12 by 25. This is the max you can go. And since they are integer vector, we would like to convert them to float vector, flip them. So get the 2D vector and now you can plug this here. Cool. Now I'll go for a sequence node, and once we update the case pointer, we would like to do 3 things. First thing is, if the discard case is active and your movement direction, let's get it from case pointer, is horizontal, then I would like to go for branch node again. I'll get the case pointer, split it, then I'll check if it is less than 19. and I'll duplicate this and I'll get the case size, split it and plug y here. And if the case pointer is less than case y, then I will do and I'll plug this here. I would like to set the case pointer and the values would be case pointer y will remain as it is. For x, I would like to go for select float, split. So basically if the movement is in horizontal direction, then I would like to pick 19. Otherwise, I will go for the case size, split, subtract 1 out of it and plug here. So I'll just go here, add 2 more pins, disconnect these two, and I would like to connect this here. Okay, and now if all these 4 conditions satisfy, I'd like to go ahead. And then once this is done, I would like to set the y value. So I'll go for another set node. Let's extend it. Now the y value can also change in such cases. Let's say you are in the discard case at the very bottom. Then if you press left, then you have to reduce y as well, because the number of rows in the case is not equal to the number of rows in the discard case. So we have to move it in the left, but we also have to take care of the y value automatically. Otherwise, it will be a very bad user experience. So same thing, just go for a select, bring out the case pointer, split it. If x is greater than equal to 19, that means you are in discard case, plug it. Then you will go for max case area. Otherwise, you will go for the case size. And after this, I would like to convert, and then I would like to get the 2D vector, flip it, and then I will pass it to modulo bounds. So this will take care of your y value, and the vector would be the case pointer. So let's bring the case pointer, connect this to this, plug it here. Okay, so these two are done, and then we would like to return, and the returned value would be the position, the new position. Okay, so let's change this to vector 2D and get the case pointer that has been updated. So okay, we are done. Save and compile. Okay, I'm sorry. I think I made one more mistake here. We have to check for the dead zone here. So let's say your primary case is of size 10 by 10, then you will become 11. So you moved horizontal. The intention was to go to the discard case. The discard case was active. You were moving horizontally, then only you can reach the discard case. And since you haven't reached there, and then we should check if you have left the primary case, then only we will take you to the discard case by pressing 19 here. So I'll just reverse this node to greater than equal to. You can go back to your inventory manager, and in the second pane you can call that function. So case actor, move case pointer, connect this to this, and the move by that we have calculated from local variables, just plug it here. This will give you the new pointer position. Once we have that, we would like to update this selected item index variable, because now the new item has been selected. I mean, there is a chance. So I'll get this 2D vector, flip it, convert this point to string. Since it's a vector, mark it true. And then we will ask slot manager that, hey, is this coordinate occupied by someone? And if it says that yes, it is present and it is also a valid index. So is valid index, and the valid index we have to check in owned items, because sometimes garbage value can be present and you might get through. So just checking whether it is present or not is not sufficient. We will check whether this point is present and it is occupied by a valid index. Then in that case, I would like to select an int, and this would be the value. But if nothing is occupied nor it is present, then the -1. That means no active item. And that's what we are going to set in this value and connect this to this. So first you check whether you are on an item. If you are, then we do something and take you to the next position that is not occupied by that item. And then we will move our case pointer over there. We will take care of the out of bounds situations. Once all that is done, the new position has been calculated. Then we will check that position occupied by some item, and based on that we will update this variable so that you can use it again here in the next movement input. And then it will go for a branch node. Now this will update the highlighted area. So basically if it's an item, then we would like to increase the highlighted area. But if it's just a normal box, then we would like to deal it with a different way. So for this, I'll go to inventory case. Under the event graph, I'll create a custom event, name it highlight case position. Remember in the widget episode, we created those events. Now we are going to use them. So we are going to call this widget instance, highlight area. So if it's just a case position, then the area would be 1, 1 and the position would be the case pointer. Save and compile. And in the inventory manager, we will check this variable. If it is less than 0, that means there is nothing to highlight. So I'll just go for true. I can call this case actor, highlight case position, and then go here. But if it is not less than 0, that means it is greater than or equal to 0. That means there is some item that has to be highlighted. So I'll go again in the case and I'll create a custom event. I'll name it highlight item, and we will duplicate this instance variable of inventory widget, highlight area again, and now top left position here, highlighted size here. Okay, save and compile, go back to inventory manager, and now you can call that same thing here as well. So highlight item and get the owned items, get a reference, select the item index, split this pin. You have the grid position, pass it here, item size. Don't forget to flip it to the vector, but this time the flip is based on whether it is placed vertically or not. So if it is placed vertically, then we need to flip it. Otherwise we don't. Okay, once this all is done, save all, compile. In the toggle case visibility of inventory case, we would like to set the case pointer to -1, 0. That is outside the primary case size, and hit compile. And in the BPC inventory manager, once you will toggle this case visibility, once this is done, we would like to create an event here in the weapon case graph, a custom event. So it will be fired when the inventory is toggled. So on inventory toggle, and now I'll call this move case pointer here, and it will move that pointer by 1, 0. That means 0, 0. And this will take care if the first slot is occupied by some item or not and all that. And this should be done only when the inventory is toggled on. So just rename the variable is open. Okay, so if it is open, then only move it. Go back to toggle inventory, and now you can call it here on inventory toggle and is open to here. And in the BP third person character, you should select the character, and here you should enable it, tick even when paused. So this will allow this trigger node to work, otherwise it will not work. So save and compile. Also do the same thing for inventory case. If it is not allowed, then it won't send the event to the inventory widget. So we should allow tick even when paused. And in the inventory manager, get pointer to adjacent box. We should only flip if the item is placed horizontally. So I'll just do not boolean. So in case if it is vertical, then we will not flip. But if it is horizontal, then we will flip. And in the third person character, the duration should be 0.12. And this structure is fine, but let's say once you release your hand, then also we want to reset, otherwise it will not move in the next press. So what I will do, if I cancel, that means if I pressed and released immediately, then also I would like to reset, and if I released after some time, then also I would like to reset. And in the get pointer to adjacent box, you have to break this pin and actually get the absolute of it. So in case this gives a negative value, we want the positive one, because the subtract could return into negative because of the differences in the position. So we would like to get the absolute value of it, and then we would like to pass it here. And now if I hit compile, and also make sure that the selected item index is set to -1 by default, that means nothing is selected. We will take care of that in the toggle inventory logic. So set this to -1, and in the grid case, make sure show discard case is set to false. We do not want to move in the discard case right now because there is supposed to be integration with the inventory case. So for now, let's just mark it false. And in the inventory case, make sure the is inventory hidden is set to true by default, because it will be invisible as soon as it gets spawned in the world. Let's also add an event begin play in case this gets checked false due to some accidental reasons. Is inventory hidden as soon as the game starts. Compile, and now if you play, press I, now you can move your active cursor. I added some debugging logs just to show you. And now if I exit and press E again, you see it starts from the 00 and now it has selected the item that is rifle. If I move, you can see it moves from the 6th position. Okay. And now if I go back from middle, then you can see it goes back to the item selection mode. And if I come back, it is exactly at the position from where I got in. And now I can collect multiple items and now I can switch between them. You can see. All right, so that's it for this episode. I hope you enjoyed it. And in the next episode, which will be the 10th episode of the inventory system, I'll try my best to wrap this up. And from there onwards, we can move to our shooting range. And the last task that is left in the backlog is to allow you to pick these items and rotate them and place them wherever you want. So I'll try my best to wrap this in the next episode. Till then, subscribe to the channel, like the video, share it with your friends, comment down your thoughts below, and join the Discord community if you have any feedback or doubts. And I'll see you in the next episode.